Hello, this is Chapter 6, video number 4. In the previous video, we were introduced to the binomial distribution, and in this video, we are going to be going over a few example problems that you might see on MyMathLab. So first one, this is directly from your MyMathLab assignment. This one says, a binomial probability experiment is conducted with the given parameters. Use technology to find the probability of X successes in the N independent trials of the experiment. And it tells us N equals 7, P equals 0.3, and finally you want X less than 4. So what we're going to do is we're going to interpret what does this mean? And these are actually not too bad of problems. These should be really, really quick when you're going through MyMathLab. So N, remember that a binomial distribution requires a fixed number of trials. This means that our fixed number of trials is 7. We have 7 trials. Probability of success is, well, 0.3. 30% of the time, this is considered successful. And finally, we're looking for values less than 4. So I'm going to go ahead and go over to Desmos. We have a binomial distribution. The number of trials was 7. The probability of success is 0.30. All right, now I want to know what is the probability of being X less than 4. And I want to caution, I know it might be really tempting to go from 0 to 4. However, we want it to be less than 4. Right now, if I were to zoom in here, let's see if I can. See if I can. All right, so right now I want it to be less than 4, but right now we're adding up 0, 1, 2, 3, and 4. I do not want to include 4. We have a strict less than sign. So I'm going to go ahead and change this. I don't want 0 to 4. I want 0 to 3. All right, and this probability is 0.874, 0.874. Now, if we were to change this, let's go ahead and say that we were to change this to, instead of less than 4, let's say that we wanted it to be greater than 4. Let's say I wanted this to be greater than 4. All right. Well, greater than 4 would look like this. I want everything that is larger than 4, so that would be 5, 6, and 7. So I would put for my minimum 5, and finally maximum would be 7. So that probability is right around 2.9%. So these problems should be fairly quick. We just have a number of trials and a probability of success, and then we have some type of range. Now let's go ahead and talk about one that is within context. So let's say that flights at a certain airport depart on time 85% of the time. Would it be unusual for less than 40 flights out of 50 to leave on time? All right, now just double check to make sure that this is binomial. First off, we have a fixed number of trials. We have 50 flights. I'm going to go ahead and assume that this is independent, that each flight being on time is an independent event. Typically, those are spaced out enough to where one should not affect the other with enough terminals. And the probability of success is constant. We have a probability of success of 85%. All right, so I'm going to go ahead and change up our binomial distribution here. Number of trials, we have 50 flights that are taking off. And finally, I am curious, about 85% of them are on time. Now remember, our cutoff for something to be unusual is 5%. Anything that is lower than 5%, we're going to go ahead and consider to be an unusual event. So would it be unusual for less than 40 flights out of 50 to leave on time? Would it be unusual for less than 40? All right, so if I want less than 40, I'm going to go from 0 to 39. All right, and the probability that in between 0 and 39 flights are on time, well, that probability is 0.119, or actually, if I wanted to round that up, that's about 12%. Now, that would be rare for only for less than 40 flights. 12% is kind of a rare event, but would it be so far to say that this is unusual? No, this is not unusual. This is not lower than 5%. So yeah, it's kind of, it's not too often, but it's not so rare that we should say, yeah, this is unusual. So those are the two types of problems that you guys are going to be having on MyMathLab. We have one that's just straightforward, straight numbers, and then another one that is within context.